Welcome to the Data Playbook podcast. It's a podcast for data leaders where we aim to build a playbook so they can get more value from data. We do that through a series of interviews with other data leaders, data practitioners, and data experts. I'm the host, Kris. I'm the CEO of Dataminded, and today I have with me an internal guest of Dataminded, Niels. Welcome to the show.
Thanks. Great to be here.
Yeah, thank you. Niels, before we dive into the topic of today, can you introduce yourself to the audience? Who are you? What's your background?
Yeah, sure. So my name is Niels Claeys. As you already mentioned, I work for Dataminded. I started my career about 11 years ago. Back then, not in data, but more in software development. So my background is more in that aspect. So I did 3 years purely software development, building APIs, building web applications. And then over time, my interest grew in the data space because the challenges that were there was more the Hadoop era, distributed computing. I liked that topic, and gradually I did more and more of these data projects. And then 4 years ago, I switched completely to working at Dataminded, where my sole focus is building data-centric organizations and building blocks. In my case, because I work on our product, building blocks for our customers or for our internal people in order to get more value out of the platform that they have.
Yeah. So you saw Hadoop and you thought, I want to do more of that?
Well, not necessarily Hadoop, but the MapReduce, yes. Yeah. The concept behind it, I really loved. The implementation was back then quite poor, and in hindsight, maybe not the right angle to look at.
Kidding, of course, because I was also very enthusiastic back then about Hadoop. And as we said earlier, just moving data from left to right is, let's be honest, is something that excites us, right?
Yes, getting a pipeline and getting the results out there, that's still something that gives joy to us. Yeah.
All right. But we're not going to talk about Hadoop today. The topic of today is EU clouds. In the last couple of months, you investigated quite some time into the EU cloud possibilities. Before we dive into what it is, can you talk a bit about why were you looking at EU Cloud in the first place?
Yeah, sure. We started looking at it, let's say, maybe opportunistically, with all the tension that has been growing between the US and the EU, the talks of Trump. We saw that quite some clients were thinking, okay, maybe the US is not a reliable partner, and what is the impact for us when we use US providers. And so with that angle, we started looking at maybe it's a good moment now to look at the EU cloud. That's very opportunistically. We have seen over a longer period, the last 5 years, that the US and the EU regulation clashes at quite some points. And there have been quite some cases where GDPR of EU on a US provider had some issues because on the US you have the US Cloud Act, and there have been some rulings that the two don't match. And so there used to be the case where every company looked at, okay, as long as we store our data physically in the EU, in Ireland or whatever, that we are safe and that it complies with EU regulation. Now, lately we have seen this is not the case anymore. It's not about where is only the location, but it's more of who's the owner company, who owns the data, and that brings legal jurisdiction. So that's purely a legal term where US government could potentially also access European cloud. So that's from a jurisdictional part. So that's not my area of expertise. So I will not talk too much about it. From a technical angle, I like EU clouds because they provide an extra option. I think too long we have been in a binary decision between either we have to host and build everything on premise, or the other option is we used a US cloud in order to increase innovation, increase speed of delivery, where EU providers is, I think, a bit of a middle ground. They don't have all the fancy options that the US provider has, but they do deliver quite some value on top of what you would otherwise need to manage on-prem. So they could be the best of both worlds depending on which organization you are. So that's why we were investigating.
But it's definitely true what you say. If you look at clients, they all start on-prem. And then the binary choice that they seem to make is have to make is, do we go to cloud or not? And then cloud is one of the big hyperscalers And then usually, sooner or later, they make the decision to go to cloud because it offers so many benefits. By the way, we're big US clouds fans. We build a lot of solutions on US clouds. So technologically, it's the right decision. But it's a very binary decision, right? So they decide to go to cloud, and then once a decision is made, there is a phase of being hybrid, right? Until everything is moved to cloud. But it's very binary. But you say, well, there is a third option. It doesn't have to be left or right. It can also be an EU cloud provider, you say, or a combination of providers. Or how do you look at that?
Yeah, I think, as you say, if you are now on premise and you want to build a data platform, let's say, because we are building data platforms in a lot of cases, you might consider an EU provider to take away quite some of the burden that you have. If you want to manage your own Kubernetes cluster, I don't like to manage the control plane because it's quite finicky. If something breaks, then everything you've built on top of it is broken.
Yeah.
So if you can offload that risk, let's say it, to an EU provider, that might be a good thing. That alleviates you from the burden of managing that core infrastructure while still operating, in our case, then building the platform itself where you do have your expertise. So it's a bit of managing risk and putting your people on the right things to build.
So in a way, would you compare this move to the original move to cloud? And can you talk a bit about why you were moving to cloud, to the US clouds maybe 10 years ago? And are the same reasons valid today to move to EU cloud?
That's a good question. I think, 10 years ago, the first time I was using a US provider was AWS. I was working for a media company back then, purely in software development. And the struggle that we had there was, the classical struggle there was that you had the developers who wanted to move fast. I was building Java applications. We were back then on Java 7. But for example, there was Java 8 out with the fancy new Lambda syntax, which we wanted to use. But what was hindering us was the operations team. Because the JVM they provisioned in production, it only was Java 7. And it would take another 3 months before Java 8, the JVM would be supported. So it was hindering us in our development. Similar discussions we had for databases. Back then, MongoDB was all the rage. We wanted to have a MongoDB server, and that was not possible like that. So in order to increase that speed of development, they were then looking at, okay, in the cloud, we make it way easier for our development team to provision what they need, and we'll speed up the delivery way faster. Mm-hmm. Is this similar to the discussion now? I think if you compare it from on-prem to an EU cloud, yes, that delivers the same, but the US provider would give the same benefits in speed of innovation, let's say. Oh. Where I think back then we also looked really at the cost will be way lower. If you compare cost-wise, a US or an EU provider versus on-premise, well, nowadays we know that it depends a bit on what your business is, whether it would be a cost benefit or not. I think in a data platform world, in a lot of cases, it does make sense because you have spiky workloads. You don't have a constant flow. Your jobs are not constantly running. So if you can dynamically scale well, then I think a US or an EU provider could still make a lot of sense.
But then when we talk about costs, you're now comparing to, let's say, the raw VM cost of a US provider versus the raw VM cost of an EU provider. But can you also talk a bit about, modern data platforms are not Hadoop anymore. Typically, you take something off the shelf like a Fabric or a Databricks or a Snowflake. And how do those costs compare to raw VM costs?
Yeah, they take quite a bit of a premium. They charge quite some extra money for the convenience of getting a ready to start building or a ready to use platform, while on the alternative is build it yourself and thinking about, okay, either you take a full platform, a bit like all-in-one, I think is the coin phrase that they use now, an all-in-one platform, which gets you from day one where you need to be. Or you think more, okay, what would be the best platform for my use case, and which components are relevant here?
Yeah.
So is one better than the other? No, it depends really on use case.
All right. So if you look at EU clouds today, let's dive into that a bit. where are they shining? What are they doing really well?
Yeah, I think if you look at an EU provider, you should not. They are not competing head to head with the US provider on scale or global reach, because they are so much smaller than US providers, and they cannot win this game. But where do they shine is, I think, in two facets. And one being, if you are in a highly regulated industry, they give you some peace of mind that you don't have that clash between the legal discussion, which I highlighted in the beginning, but you are sure that all the rules and regulation that the EU government puts out there, that they will comply with that.
Yeah.
And you don't have a conflicting ruling from a US, from the US government, for example. So that's an angle, highly regulated industries. What I also really like about the EU providers is they have an incentive to think more about an open ecosystem and using open standards, because they don't have the volume or the amount of customers that they can push certain proprietary software. They focus more on keep it open. We use open standards. We use open building blocks from the community, and we manage those, which gives you by itself a bit of a more flexible platform.
Yeah, absolutely. And so you investigated several EU cloud providers, and actually you built a data platform on top, I guess using those open standards.
Yeah.
So what did you find? Maybe starting with the platform itself, what kind of platform did you build? And then dive into the cloud providers, and how did you deploy that?
Yeah. So the onset of, or the goal of the research where we started at Dataminded was that, okay, we have built a lot of data platforms on AWS, on Azure, on Google Cloud. What if we would do the same on an EU provider? And the first thing was, okay, what would need to change? And then in the first angle we took, okay, what do we actually use from these, or need necessarily from these providers before we can start building a platform? And we're not, our core business is not maintaining infrastructure, so we want to have some services managed. And we looked at those and we said, okay, what do we need? We need storage. We need blob storage, block storage. We need...
Sorry, for the audience, what's the difference between blob and block storage?
Yeah, so blob storage is object storage. Yeah. So it's typically what an S3 provides you. Most of the EU providers, they comply with the S3 because it became a bit standard in our industry. And block storage, those are disks, disks that you attach to your database, to your laptop, to a machine. Okay. So that's different. So we need that. Mm-hmm. And then what enables these EU providers to deliver a lot of value is the fact that almost all of them provide Kubernetes.
And for those listening who have heard the word Kubernetes but don't know what it is, can you explain in layman's terms what's so cool about Kubernetes?
So Kubernetes is an orchestrator, and what does it do? Is it's a flexible way to manage compute workloads. Any type of compute, and you can configure it, and it can scale it down and scale it up. So it's a way to run arbitrary jobs on top of hardware in a very flexible way.
Okay. And that is also an open standard, or is it proprietary technology, or what is that?
So that was initially developed by Google. Borg, that was the platform that they used internally for running their applications, and they open sourced it. It's now the part of the CNCF Foundation. So it's an open standard, and you have a lot of providers who support or manage or provide this as a managed service within their platform. So as long as you can adhere with the Kubernetes APIs, you can port whatever job you have running on Kubernetes on AWS to an EU provider, or on-prem. We also have on-prem hosted versions, an OpenShift, for example.
So if I understand correctly, what you were looking for from cloud providers was block and blob storage, a way to run VMs, and a way to deploy Kubernetes on top of those VMs. Am I saying that correctly? Or
yeah, that's what Kubernetes, it implies that it needs those VMs. So Kubernetes as a whole gives links the VMs to what you can deploy on.
Okay, got it. All right.
So if you have that, we can do a lot of things. And why is Kubernetes so vital for these EU providers? We already mentioned the US hyperscalers. They have, AWS has now maybe 500 services. The EU providers have maybe between 20 and 50. So there's a huge gap there. But what's cool is, since Kubernetes is this huge ecosystem, you have a lot of open source components that you can install on top of Kubernetes that can fulfill the same capability as a US managed service. And for example, you could say, I don't have a secret store within my EU provider, but I can manage the secret store within Kubernetes. So that way, you still have a way to tweak the EU cloud provider to have all the capabilities that you require for your platform.
Got it. Yeah.
So that was the starting point. Okay, what do we need? And then we looked. Okay, most EU providers have these building blocks, and then it was okay. What do we build on top? How does this platform look? And there we looked at. Well, we keep it simple. So we started with baseline. Okay, we want SQL endpoint. We've done quite some project where core functionality that we need to provide is scheduling and a way to run SQL. So a data warehouse plus a way to schedule our jobs that delivers already a lot of value as a starting point.
Yeah.
So that's where we started, and we said, okay, what do we need to implement this stack? And so as a SQL endpoint, we use Trino. Trino, the new version of Presto, which is, for example, also what Athena in AWS it runs behind the scenes. But it's an open standard. It's an open standard. It's open source. So that's and we have been using it in the past for one of our projects, and we're quite happy with it. So that's why we started with that.
And what does it do? What is Trino for those who don't know?
So it's a distributed SQL engine. So what it delivers you is a SQL endpoint. You can run SQL queries, and it can integrate with different backends. It can be object storage and some tables you have stored on S3, but it could also be another database, and it can connect to those, and it will manage that query and distribute it the way it's needed. And for you, it's just writing SQL. Select star from products, and the products table could be on S3, could be in another Postgres database. It's quite a flexible way in handling.
Yeah. So it manages that for you, and you only need to focus on the SQL.
Yeah.
All right.
Yes.
Okay. So that's one component.
So that's one key component. Second part is, okay, we want to schedule jobs. It's not enough to have a SQL endpoint where you interactively can run queries. You want to schedule them every hour, every minute, whatever is needed for your use case. So for that, we use Airflow. It's the same as we use in all the other stacks. There are, of course, alternatives, but we have the most experience with Airflow. So we said, okay, we pick Airflow for scheduling.
And again, for the people who are listening, what is Airflow?
Yeah, so Airflow gives you a way to write scheduling logic. And what is scheduling logic? For me, it's two things. It's how certain jobs are interlinked. And you say, I want to run job A after B after C in order to get to my desired output with then the time component, or when does it need to run?
Yeah.
So do we want, for example, your sales report? Do we want it once a day? Yeah, okay, we schedule this to run at midnight so that you have the report of what were the sales of today early in the next morning.
Yeah.
So that's the raw functionality. What made Airflow, I think, revolutionary already, let's say 8 or 9 years ago, was the flexibility in writing the scheduling logic. It's written in Python instead of what back then was either click-based or YAML files. And because it's Python, it gives you a lot of flexibility in how to combine these jobs.
Yeah, it's almost the de facto scheduler in the data world. I know there's others like Prefect or Dexter, and I mean, we're not going to have the debate which one is better, but we see Airflow a lot, right?
Yes, I think it's a de facto standard, so everyone knows it. None of our customers need to question or wonder why did you choose this tool. They often have already experience with it anyway. So that reduces the burden as well to introducing this technology.
Got it.
And then the last part is, okay, how do we store our data? And then there, well, recently the evolution is becoming a table format. So we have blob storage on S3. That's typically, okay, you could say Parquet files. But recently we've been all using tables and table storage because they give a way more flexibility in schema evolution. They give better query performance. And there are a couple of standards you could look at, Iceberg, Delta, Hoodie. But I think at the moment it seems clear that Iceberg is winning this game. So we said, okay, we're going to store our data in Iceberg format on top of S3. So that's actually Parquet with some small metadata that is stored on S3, S3 compatible in an EU cloud. And then we, so that's actually our data.
And again, for people like for you, it's kind of obvious what is Parquet and what is Iceberg. But for people who are less familiar with the technologies, can you walk from if I'm a data analyst and I know Excel really well, and maybe I've seen a CSV file before, like what does Parquet bring that CSV doesn't do? And then once I understand Parquet, what does Iceberg bring that Parquet doesn't do?
Yeah, sure. So if you are used to a CSV file, you see, okay, you have rows, and let's say I'm for a customer, and then you have properties. When you say, okay, the customer, if you talk about me, I'm Niels. First column would be my first name, last name, my age maybe, and whatnot. So you have columns, and in a CSV file, you have that for every customer. So it's actually row based. So you say, okay, you have entries for every row. Now, what we do in the data space is we're often not very interested in individual rows or individual users. We're more interested in doing calculations on top of all the customers that we have. And we want to, for example, look what's the average age of all my customer base, or segment this. So we're not looking at the rows, we're looking at the columns. More, and then over all the rows instead of individual rows. So that's actually what Parquet does. It stores its data columnar, so on the column level and not on individual rows. What is the impact is that you can very efficiently run queries or aggregations on top of all of your customers or all of your rows, in this case. But you cannot easily ask, give me all the properties of Niels again, because that's actually mixed all over the file.
Yeah, well, you can, but it's slower.
Yes, that's not efficient. So that's what Parquet brings you. That's the standard at the moment. We store all the data, both in a table format as in pure Parquet. You store it just as is in blob storage. What does a table format give you extra is the problems with Parquet arise if you have, for example, well, we're going to change some columns, or the format of how do we store our customers is changing over time. How do we handle that? And we have old data which doesn't have all the properties and new data that has extra properties, or maybe some properties get deleted. Do we need to rewrite every Parquet file now to adhere to this new schema? Or have we gotten another way to deal with this? And that's, for example, one of the things that Iceberg does, handles for you. And this schema evolution. There are other things. If you want to fancy partition your data, so I don't know how technical the audience is, but you have this Hive partitioning scheme is very popular. You say, if I want to store my sales data, and let's go back to sales, for every year, you often partition it. Okay, you have year 2025, and then a month, and then a day, and then you have your sales per day. This is what we call Hive partitioning, and this is how we store the different Parquet files on the blob storage. Now, what is the problem here is that this works really well as long as you are interested in querying the data, the sales of a day or a month, because that's how it was stored. This is not flexible if you want to say, I want now an overview of all the sales I did. That basically means I need to cut all records, but I have a certain other dimension I want to query it for.
Yeah, like region or something. I only care about US sales.
Yes, for example. That's very poor in Parquet. And that's why these table formats, they have some metadata, they have some statistics extra that will help you find the right Parquet files that they need to search for these other properties. Okay. So that's what a table format gives you as extra on top of what Parquet gives you.
All right. I actually honestly didn't know that last bit. So I learned something.
glad I could tell you.
No, that's very good. Okay, so we were diving deep into table formats here, but so you were talking about the tech stack. So you had SQL endpoint, you had with Trino, you had scheduling with Airflow, and you had storage with Iceberg, right?
Yeah.
All right.
So I told you about storage. We have a couple of other components that we added to the stack, and maybe it's good to highlight that. So in order to fulfill this need for storing Iceberg data, you typically have a catalog. I call it a meta store, but people will know it as a catalog. And in Iceberg terms, this typically means an Iceberg REST catalog. It's basically an API that can serve you Iceberg tables.
Yeah, and it's different from a data catalog, right?
Yes,
it's a very technical catalog.
Yes, this is purely a technical thing, which is needed by the query engine, Trino in our case, to know how to fetch the right files. It's not a data catalog in giving all the semantics or who is the owner. It's purely a technical thing that your query engine will need, and that Trino in our case needs. And we chose for Lakekeeper, which is one of the popular catalogs now, supporting Iceberg, because it has quite some interesting features, but that goes a bit too technical maybe to discuss all of that. So Lakekeeper we need. And then another interesting component is OPA. It's an open policy agent, which works well in the combination between Trino and Lakekeeper. And why do we need this? This is actually a component that we will use to handle fine-grained access control to our data. So it allows us to write custom policies to say certain users can only access this table, or certain applications have only access to this table. And that allows us to make a fine-grained access policy, which would otherwise in a portable way be very difficult, because then you are reliant on the support of IAM within that cloud provider. Now we can put that in our platform. We can secure that ourselves, and we don't rely purely on the cloud provider to have these fine-grained rules, which also don't really exist in this EU provider. So that's an extra burden that is more needed here than that it would be needed on AWS. You have IAM, which is super flexible, super fine-grained. There you would not need it, but if you want to build a portable platform, you need to build it yourself.
All right.
So with Lakekeeper and OPA, then we have all the necessary building blocks that we need for a data platform stack. There are some technical components that we added as well that I will just mention here. Is Zitadel, which we use for identity and access management. It's a component that we use for identifying users, but also applications, and that would then integrate typically with your identity provider if you use Entra ID on Azure or whatever SSO setup you want. This you could use, and it's a component that allows us also to create applications and login flows and all the typical things you need from an identity platform.
Because correct me if I'm wrong, but what you typically don't want to do is manage your own database of username and password and forget your password, and then if someone exits the company, then you need to remove them. You don't want any of that. No. So you just want to sync with whatever identity manager that the company already has. Yeah. And Zitadel does that for you.
Yeah, Zitadel integrates with all the big ones in this case, and that's what you need. Yeah. So that's what Zitadel does. Yeah, and then a small other component, it's Traefik. It's let's say the proxy towards all the application that we build on the platform. It's a bit of a reverse proxy, and Nginx could be an alternative. But we use Traefik because it integrates well within the Kubernetes ecosystem, and that gives us the full stack of what we have built, and that's also the complete stack of what you will find available. And we will share in the show notes, I guess, the Git repo, which is open source, where you can find this full stack and get started if you're interested in using this.
But that's actually interesting. So you listed a whole bunch of components. You put it all together to have a platform that is independent of clouds. And we're going to talk about the cloud providers in a bit. But I want to stay here for a bit. So that repo is open source. Everyone can do just git clone and then use it. But what they'll see in that repo is it's very much a best of breed approach, right? It's not there's not one solution that does everything. It's you take a bunch of open source components off the shelf and you combine it into a best of breed solution. This is an endless debate, I know. But what are the pros and cons of such a best of breed solution, and why should you consider it? And when is it better to go for an all-in-one?
Yeah, that's a difficult question to answer, because the typical consultant would answer it depends on but that's not very helpful. So let's break it down a bit more. What I think you should, as a company, always do is think, okay, what are the capabilities that your data platform should have? We discussed the SQL endpoint, scheduling. Those are, for me, capabilities. Securing it is, of course, very important. Not give everyone access to all the data. Well, that could be a policy, but has also some inherent risks. And then look at, okay, how would you create a platform that can evolve over time? And I think in that sense, I try to fit in certain, let's say, all-in-one platforms for certain capabilities because they do it very well. So you could use a Databricks if you say, I like the notebook functionality. I like the fact that they integrate with the catalog a bit like that I don't need to manage that aspect, but that doesn't mean you need to take everything from Databricks. It should fit in, okay, maybe we want to do scheduling still in another way. Maybe we still like Airflow as a scheduler, but we just schedule jobs within Databricks. So I think you should always try to look at your platform as something that can evolve, and certain products will take away quite some components of it, but the idea is, since if you have these capabilities, that you can evolve them over time, and it might be that over 5 years, Databricks is not the best solution for you, and you want something else.
Yeah. So to play devil's advocate a bit, and I follow your reasoning, but if I choose Databricks, right, why would I not do scheduling in Databricks?
Because the flexibility or the visibility that the scheduling of scheduling in Databricks is limited. It might be that, for example, you have certain jobs that run on premise and that have nothing to do with Databricks, and that doesn't fit within what Databricks offers.
Yeah.
So, and then it's thinking, okay, do we want then to use one other scheduling tool that can be used for all of our platform, or do we do certain things in Databricks and whatnot? Dependencies between these jobs. How will we configure a certain job in Databricks that is dependent on something that has run on-prem, a sync job that uploaded the data to your cloud bucket, for example? So those are the challenges. I think you should always look at how can we integrate it in our full organization. And there is always a lot of glue around any all-in-one platform still needed to fit it in your organization. And you should think about, okay, what is worth the glue, and if some things maybe I want to build off on the shelf myself, and some things I just want to take off the shelf because I'm not going to build this.
So you mentioned a bit the advantages of best of breed, and I fully agree that it offers you a lot more flexibility. It's easier to tailor to your specific organization, to your needs. Is also when you see when you base yourself on one platform, you go all in one, and it lacks a feature, then you're kind of stuck there. So, but if you go best of breed, you can still use those tools, but as part of a stack. So those are all advantages of best of breed. I see those, but what are some disadvantages?
What are disadvantages of best of breed is well, I think it can be often costly to do this integration work. And because if you use the best of breed, you typically use maybe off-the-shelf components of different third-party vendors. And then how do you fit them together? Most cases, I think what an all-in-one platform does well is the integration part. If you look at the Google stack, the components are very well integrated. If you look at Databricks, everything you do within that platform is super well integrated and super easy to configure. But once you go outside of it, it becomes more difficult. So that's a downside of a best of breed. You have more glue work or more work in combining these different components together.
No, you're absolutely right. Because to give an analogy, and it's nothing to do with data anymore, but we internally in Dataminded, we chose to go for HubSpot as our marketing and sales tool. And that's not best of breed. That's very much an all-in-one tool. But it's like for the size of the marketing and sales team we have, and the time we have available to do the glue work, which is none, we're going to go for an all-in-one solution. And we realized that for every single component that HubSpot offers, there's probably a better alternative in the market. We kind of locked into that platform for a bit, but we accept, like, it was a positive choice, I would say. And I think it's the same for data platforms, right? We have to make a positive choice, whether it's left or right, but like, do I want to go all in on one platform because I believe that's best for me? Then I can live with the drawbacks, go for it. Or do I want to go for best of breed because I want that flexibility, but then you have to accept the extra engineering work to do all the glue, right?
Exactly. I think options in this case bring conscious decision making. Because you have multiple options, you think about, okay, what are the trade-offs? And then you can make a well-informed decision.
Yeah.
And that's I think, the key in building a platform or in any of these cases. Yeah.
So let's dive one level deeper. You talked about building a cloud-independent platform. It's available on GitHub. We'll indeed share the link so people can do git clone and play with it. But that needs to run somewhere, right? And then the whole point of this was it can run now. You can deploy it on AWS if you want, or on your server that you run in your basement, but the point was to deploy it to EU clouds, right? So what are your experiences like with the different providers? Which providers did you look at? How did it go? Walk us through that journey.
Yeah, so we've started by identifying, okay, which EU providers exist, and then qualifying them on, do they have the prerequisites? And to look back, the prerequisites were, do they have blob storage? Do they have Kubernetes as a managed solution? And then do they have load balancer or a network stack? But okay, that should be there. So we looked then at Exoscale, Scaleway, UpCloud, and OVH as 4 big providers that exist that were also still easy to use. With easy to use in the sense, I mean, you could... it was self-service. Let's call it like there are other providers out there, and this is not an exhaustive list, but we had some examples where, well, it felt like this self-service way, or just hooking up a credit card and starting playing with it was not as trivial.
But that's important for you. Like you just give a credit card and you want to play self-service.
Yes, in this case, yes.
Yeah. Okay.
So we looked at those 4 providers and we said, okay, can we build the stack that I explained before? Can we run this on these providers? So of course we need to do some basic infrastructure. So we need to set up all the S3 compatible storage buckets. We need to set up the managed database. We set up Kubernetes, and then we deploy the applications on top. And from the get-go, we noticed that, okay, the portability of this stack is great because everything works. You can deploy that on all of these providers. So that's the good news. And I think what I want to stress is that we as a, let's say, skeptical EU citizens, we are often downplaying the capabilities of the EU platforms. Like, okay, they are crap, they're not great. You cannot use them for anything practical. Well, with this data platform, we noticed that, well, this works. This is not more difficult than you running it on a US provider. So in that sense, I want to be a bit positive here, that I think you can build great products and good platform on top of all of these EU providers. But there are still some drawbacks.
Yeah.
There are still some things we struggle with. But one of the things we of course need is we are data engineers. We like to manage everything through code, infrastructure as code as well. Terraform provider, they all have. Yeah. But using the Terraform providers is sometimes not as plug and play as any of the US providers, because you need to do some hacks sometimes to use, for example, S3 backed storage. They all use the same API, but then you need to configure some magic parameters in order to make it work on an EU provider.
Yeah.
No rocket science, but you need to get that through. So it works. While trying to figure out how to build this platform, or when you hit certain roadblocks, you do notice that the joy of a US provider is there is so much knowledge on the internet. It's so easy to go to Reddit, to go to Stack Overflow to troubleshoot a certain problem. On these EU providers, the only thing you have is their own documentation, which is also still limited. So troubleshooting issues take way longer on these EU providers than it is on a US provider, both because the documentation is limited and, well, there are few people, relatively, of course, that have been through this game.
Yeah. Okay. All right. And can you mentioned a few providers there, like Exoscale and UpCloud and OVH, and can you walk us a bit through which one did you like the most? Why did you like it the most? Where were you struggling, or was it comparably all the same quality?
No, I think we looked at on a couple of axes. What do they provide, and where do they perform well? One of these axes is, for example, which services do they deliver managed out of the box? And I talked the basic services that we needed for the platform, but there are some other services that could be useful. And for example, if you deploy applications on top of Kubernetes, you need a container registry where you store, okay, what is the image that you want to run?
Yeah.
For example, that's a service that's not provided by all of these providers. For example, UpCloud doesn't have a container registry yet. So then you have to come back to the initial discussion. Then you have to host it yourself on top of Kubernetes. Extra management work.
Yeah.
For example, if you look at the amount of services, I think Scaleway was top.
Yeah.
It had most services available, also quite some AI capabilities, GPUs, GPU nodes, etc. So they are furthest along on the services part. Other things we looked at, I think what is maybe interesting to mention is of course cost. Cost is comparable. There is no big reason to go for one or the other. Costs are the same, with I think the exception of OVH, which is consistently quite a lot cheaper than the other EU providers and also the US providers. So if you're really concerned about cost, maybe OVH is more interesting.
But what I hear from you, you're skeptical yourself. You say that shouldn't be the main.
No, I think if you compare these platforms, you could get some cost savings, but I think the usability, what is managed, what is provided, is more important than this raw cost, because it's difficult to take into account the full end-to-end cost that you would have.
You also said UpCloud doesn't have a container registry yet. So is this a fast evolving landscape?
Yeah.
Or?
Yeah. So if you look on their website as well, they give a bit of, like any good product, they give a roadmap on, okay, what are the things we are working on and what are the things that are still still planned as a next phase. And for example, a container registry is one of the things they have planned in the near future. They didn't start on it yet.
Yeah.
So it is fast evolving. I think if you would compare the state of the EU cloud providers now versus 2 years ago, it's a completely different view. And they would be by no means far enough for us to start using them as they are now. I think they are usable, the core components. I think there are two other aspects I think what are interesting to look at. We talked quite a bit about the security point of view and encryption security and what do they do there. And I think there, on the encryption side, do you encrypt your data at rest? You have a couple of algorithms, and I think there, again, Scaleway and OVH turned out to be the best because they have server-side encryption where you can manage your own keys. A bit more management, but gives you the most security. You as a user decide, I have my keys, I can store them wherever I want, and I encrypt my data. And the cloud provider doesn't have access to those keys. For UpCloud, at the moment, they only have AES, which is still encrypted, but it's symmetrical, so they have the keys to decrypt that as well. It gives a bit less security, but they are working on server-side encryption with customer-managed keys as well.
Got it.
And then the last part is a bit what we call technical lag, and that's more on, okay, how fast do they adopt new versions of, for example, Kubernetes or new versions of Postgres. And that's to see, okay, are they following the open source release cycle, or how far are they behind? And I think there they are comparable to what an AWS and what an Azure does. They are not far behind new releases of Kubernetes. I think the exception was a bit UpCloud, which was, let's say, 6 months behind instead of 3 months, which was the rest.
Yeah.
So I think that those are all quite good benchmarks, quite good. Performance-wise, this is quite good and way better than I expected also in the beginning, to be honest.
All right. Earlier, you talked a bit about the importance of open standards and that EU clouds are more incentivized, at least, to work with open standards because they don't have the scale to try to lock you in yet. So can you talk a bit about that? Like, what kind of standards do they support and how do they support it? What does that look like?
Yeah, I look at it mainly from let's say, the data platform side. And if you look at what they are building as data platforms, so for example, Scaleway has a managed data platform. OVH is also thinking about the managed data platform. And if you look at what the stack looks like, it looks very similar to what we've built. It uses Trino, it uses Iceberg. So they typically take, again, these open source components and they give them a managed version. That is very different from, for example, what Azure does with Fabric, where everything is more like a black box.
Yeah.
You can use it, and then they give an interface to play with, but it's very rare that you see the individual open source components. Makes it also way more difficult to transition from Fabric to something else. Same thing you had before with Glue. We within the product at Dataminded had a lot of issues with integration with Glue because it's a thing on their own, and it doesn't comply exactly with what we needed from a data catalog. It was not fully Hive compatible back then. Now they do support the Iceberg API, which does then comply more to the OpenStack. But I think indeed the US providers are more incentivized to lock you in than the EU providers. Another place where you can see that, for example, is with egress cost. The US providers, they charge quite heavily if you want to get data out of their platform, which, well, is fair. They are the biggest. They want to keep you there. If you look at almost all of the EU providers, their egress cost is free.
Oh,
so
really?
It's zero.
Yeah.
So that of course, that maybe unlocks also some capabilities where you say, okay, we can store some data and we can get it out. It doesn't cost us anything extra. For certain backup scenarios, it might be useful. I don't know. So they do have some angles where they could deliver extra value.
And to be fair to the big players, they are at least paying lip service to open standards, right? Like Snowflake and Databricks are also embracing Iceberg, as far as I understand. I think Databricks even bought a company behind Iceberg, right?
Yeah.
Tabula.
Yeah. So indeed, the whole data space is in general also more evolving towards open standards, where it used to be maybe even before my time, because Hadoop was often based also on an open standard. Yeah. So, but before that, typically closed source solutions were the norm. So I really like this evolution, because it also gives a lot more options to evolve your platform. You have new tools coming out that that integrate with these open standards, and you can immediately start using them. And you're not locked into an archaic system that you cannot get out of easily.
Yeah, I agree. Where when I started a long time ago, there was Oracle and IBM and Microsoft SQL Server, and that's where you did everything. And then Hadoop was like the hippie space, right? It's true. I like you had things like Zookeeper and Pig and Hive and and a million other components, but it was all open and free, and you could do whatever you want. You could run it on commodity hardware, which turned out to be very beefy machines as well. But that was really the land of the free, if you will. Yeah. But then I think we went a bit overboard there. It was way too much management. Cloud came, and people saw the value of standardization. But I felt lately that we've been too much on the other side again. Like, no, we choose platform A and we do everything in platform A, and we're not even looking at technologies B and C. So it's good what you say now. I like to hear that, okay, the wave is slightly going in the other direction again. Like, okay, we're at least looking into open standards so that we store our data once in Iceberg, and then we can have many compute engines on top. I think it's better for the whole ecosystem, right?
Yeah, fully agree.
All right. So maybe that brings us to the future. If we do this podcast again 2 years or 5 years from now, where do you see this going, the EU clouds?
Yeah, I see, well, let's say two angles, but maybe let's start there. I don't see the EU providers competing head-to-head to US providers on scale or global reach. I think they will not get there. That's one side note. So one of the things I think that I do see it going to is that they will carve out a niche where if you are in a sector which is highly regulated within Europe, the finance sector, the medical space, government, that they can provide there a niche, let's say, they can play an important role to keep your data safe, compliant with whatever EU regulation will be there. So in that sense, it gives you peace of mind because you don't have that conflict. But that also means that probably I see a value for more EU regulation on certainly certain types of privacy-sensitive data. Okay. I think we had quite some steps there already. You had the GDPR, you had the AI Act. I think for certain data, it would maybe be good to have also an act on, okay, this data is sensitive and maybe it should only be managed by an EU provider, which complies to fully our laws, and we don't have that conflict. So I think that could be the main angle that the EU providers could take. They could carve out a niche where the US providers are not, can never compete in.
Yeah. And so that's very, that's very much on a strategic level. How do you see the technology stacks evolving?
Technology stacks evolving, I think they will continue to improve. So they will add the services that we need. They will adopt over time. They have the right basis of services, and they will adopt, I hope, in the future as well, all the open standards that come up and that you want to use.
Yeah.
I'm not a visionary there, so I might be completely wrong. Maybe they go fully on-prem, fully vendor locking, but I don't think so.
Okay.
Their incentives are not there, so that's the nice thing.
But then let's bring us back to the present. If I want to get started today with an UpCloud, can I get my hands dirty?
Well, yeah, I would say go to a repo. Certainly, if you want to build a data platform, go to a repo. What do you need for that? Is then, well, you need to have an account on one of these providers: UpCloud, Scaleway, OVH, Exoscale.
Yeah.
Those are the ones we tested. So creating an account there is as easy as going to the website and attaching your credit card, and then you can start playing. Most of them have also a very generous initial sign-up fee where you can play around for 100 or 500 euros of free credits where you can start playing, and then check out the repo and deploy your first platform, or build another hobby project where you say, I just need a VM and I want to deploy my simple web app, and just start playing and feeling how difficult is this, how easy is this how easy it is to get started. Yeah.
Okay, so I do a git clone of the repo. I have my credit card linked to an account. What do I do? Oh.
Yeah. Well, so we manage everything as with infrastructure as code and Terraform. So you use Terraform or Tofu in our case on the basic building blocks, and you say, okay, Exoscale, go to the folder Exoscale, Tofu apply. It installs all the basic infrastructure, Kubernetes, storage, the database, etc. And then you deploy all our platform applications, Trino and Lakekeeper and OPA, using Argo CD. So we have install script for running Argo CD on that cluster, and then you just and then it will sync from the repo all the application deployments that need to be done.
So if I understand correctly, all the cloud infrastructure you provision with Terraform, but then everything on Kubernetes you manage through Argo CD. Yeah. All right.
You could also do everything in Terraform if you prefer. Then you need to change a bit what the repo is, but the current repo indeed uses Argo CD to deploy all the applications.
All right, that's very exciting. Final question. You've been in this space for a long time now. What do you know now that you didn't know when you started in data? In other words, what is the advice you would give to people starting in data today?
I think keep things simple would be the main advice that I give, because as you start, you typically want to use all the most fancy and new technologies without really understanding why they are needed or what you want to build. So start with the basics. A pipeline running SQL on top of PostgreSDB for 80% of the use cases, that's more than enough. You don't need Databricks or Snowflake to run a SQL query on a million records. You can do that on your own laptop. So keep it simple, and then understand in which situations do I need something more and why would I use a certain tool.
Given that you give this advice, keep it simple, I guess earlier in your career, you didn't keep it simple?
Yes. I was really, in the beginning of my career, following this hype train of new technologies, and I want to use the latest new and fancy technology. I already discussed a bit the MongoDB course. So we had a Postgres database, and I wanted to migrate it to MongoDB because document storage is what you need. In the end, it didn't turn out that great. Postgres could handle more workloads than we could then in MongoDB, because we just were not using Postgres the right way. And the same thing with the whole streaming saga. I was jumping immediately on the Kafka train, and then in hindsight, streaming is way harder than batch, and we were not doing the right use cases with Kafka. We could have done the same with a batch workflow instead of writing everything streaming, but it was cool. I wanted to learn the technology, but for the company, I don't know if it was always the best.
All right, those very wise words to wrap up. Niels, thanks for being on the show, and good luck with the EU Cloud endeavors.
Thank you.